Good afternoon, everyone. I'm Haiming Liu. I'm now working as a research associate with the Metaverse project at Laurentian University. And the title of my presentation is Multivariate Statistical Analysis of Lithogeochemical Data of the Larder Lake area. And here are the data analysis members. My role in this team is to investigate the Geochem data, and we are trying to build mineral potential maps for mineral exploration. And here is the presentation outline. Today I'm going to give an introduction about how we use our Geochem data to build mineral potential maps and how we process our Geochem data. One case study area is Larder Lake area, and we run several multivariate statistical methods such as principal component analysis and distributed stochastic neighborhood embedding. We call it Nipissing and random forest. And as machine learning techniques has been a popular research topic in the field of mineral potential mapping. In general, machine learning algorithms can be classified as unsupervised and unsupervised, supervised, and reinforcement learning algorithms. And the data analysis combines all of the analytics and advanced analytics to explore the insights that are hidden in the data. And so our data analysis team for Metaverse is try to visualize data, describe statistical characteristics of data, and find distribution patterns, cluster data, and build classification models. And then we try to make some predictions. The final target is to generate the mineral potential mapping for mineral exploration. But at the beginning of any data analysis, we need to prepare very good data set. Here, this table shows that a data set that has a lot of issues, such as we can see the trace element here, but we don't know the unit for each element, such as they are in ppm or ppb level. And the analytical method was not clear. And in the data site, there are a lot of zeros, missing values, and below detection limits values. But if we look at this data set, we can see that the unit is very clear and the analytical method is marked. So in this study, we use a generic approach to process our Geochem data set. The Geochem data was collected from various sources and should be sorted in a consistent format. Then we screen our data according to this criteria. For multivariate analysis, all the data sets should be complete. So we use different imputation methods to impute, such as the values below detection limit, above upper detection limit, missing values, and then we use the QQ plot to check our imputation quality. And we ran several multivariate statistical analysis after the centered log ratio transformation. Here is a case study. Here is the geological map of the Larder Lake area. So we saw very clearly that there are two major deformation zones: the Larder Lake Cardiac deformation zone and the Nipissing shear zone. Along the mafic, antromafic Larder Lake deformation segments, there are considerable metal endowments and associated with major orogenic gold deposit. In contrast, there are mafic to felsic intrusions along the Nipissing shear zone and are associated with gold mineralization events. In this study, we focus on three major deposits. The largest one is the Kerr organic deposit, the Chamonix deposit, and the Nipissing shear zone, Nipissing deposit in the south. The Geochem data sites compiled from mining companies such as Goldfield, Gold Candle, and the Metaverse database. Here are the principal component analysis results for Kerr artisan. deposit outcrops data. The biplot is a very easy way to visually express the relationships of variables and distribution of observations across a pair of principal components. The PC1 and the PC2 biplot shows the distribution of samples is dominantly controlled by lithology, and the high copper, nickel, chromium, iron, and zinc and magnesium correlated together can characterize the gold rich ultramafic rocks. The PC2 and the PC4 biplots can distinguish the gold mineralization and alteration. It highlights that the high gold grade rocks are associated with bismuth, tellurium, sulfur associations, and low gold grade rocks and barren rocks are associated with this element. And the relative contribution plot shows that the contributions that an element can make over all the components, such as here is the Kerr and Geochemical dataset. The gold has the largest and the second largest contribution on the PC2 and the PC3. And if we plot the biplot of a PC2 and the PC3, we can see that the gold is associated with a sulfur, tungsten, and arsenic. This can be characterized of the high gold rich samples. And these are the PCA results for Sherman outcrop data. Eigenvalues measure the amount of variations retained from each component and principal component. For screen plot, the plot of the eigenvalues are ordered from the largest one to the smallest one. Eigenvalue larger than 1 can be used to indicate that the principal component accounts for more variance than original variables in dataset, and most of the variance or correlations are contained in the dominant principal components, such as the lithologies or rock groups. And but the lesser principal components can be used to identify those rare event process, such as that are undersampled, such as the mineral exploration targets or alteration patterns. For Sherman deposit outcrops, the first and the second principal component account for lithology, such as Larder Lake groups, can be identified in the biplot, and according to like the nickel, copper, chromium associations. While these elements can be used to recognize the intermediate intrusions, and the PC2 and the PC3 can be used to identify the carbonate anchorite alteration based on the calcium, magnesium, and silica associations, which are associated with gold mineralization. And for the Geochemical dataset, the gold-rich ultramafic rocks can be recognized from the PC1 and the PC2, and the gold, we can see that from the PC3 and the PC5, the gold is associated with sulfur, copper, and this indicating that the gold mineralization can be reflected from the PC3 and the PC5. And the element versus a loading plot shows a high variance of a gold with sulfur and minor copper that on the PC5 directions. For Nipissing area, the PCA plot shows different distribution patterns because there are more intermediate intrusions from PC1 and the PC6. We can see that gold is correlated with sodium, uranium, and strontium for high gold grade rocks. So indicating that the sodium-rich fluid may be associated with gold mineralization, such as alpitization alteration. This is consistent with intense albeitization observed in the intrusive rocks at the McGregor trenches. And here are the summary of the PCA results for individual data sites along the Larder Lake area. And from the table, we can see that the Kerr, and the Chamonix deposits they have very similar lithology structure with the lithology structures, and the detailed investigation of the correlation relationships reflected from projections of a principal component backplot can help to identify geological processes and the geological boundaries. After investigation of individual data sets, we combine all the data sets together, and we can see that PC1, PC2 can be used to identify the major lithology of all the data sets, and high gold grade rocks can be identified from PC2 and PC4. T-SNE is an supervised nonlinear dimension reduction tool. It allows to better separate the data and visualize the high dimension data in lower dimensional space. It works very well to capture the major differences in the Geochem data site and define the geological context. Here, from the plot, we can see that all of the data can be clearly classified by the major lithology, and it shows very similar classification with the PCA results. To recognize the association and the distribution patterns between elements, we projected the coordinates on major principal component directions, which shows the geospatial coherence. And this can help to identify the mineralization processes, such as alteration and gold mineralization. For instance, the PC2 and the PC4 can help to identify the gold-rich rocks. And also we can see that the principal component transformation data can perform better to recognize the mineralization targets than using the single element in mining. The lithology for Kerr geocore data is well studied, but the lithology for Chamonix geocore data was not clear. So according to the similar PCA result for Kerr and Chamonix, we ran the random forest to predict the major lithology information for unknown samples. As Jeff introduced, random forest use multiple decision trees to make classifications. In this study, we use 70% of a data set from Kerr geocore data, and using 30% of the data as a validating data set. For the whole Chamonix data geocore data are unknown samples, we use them as the test data. And here are two parameters that needs to be tuned in random forest. One is the number of the trees. Here we can, from this table, we can see that after like number 5, the errors is quite stable. So we use the numbers of trees as 500. And also this chart shows the numbers of nodes for the trees. In final, we set the numbers of the trees at 500 and 8 as the number of nodes. The confusion matrix is the very simple way to evaluate a random forest model. And here we can see the overall out of a bag error estimation is 3%, which means the accuracy is around 97%. And in the confusion matrix, we can see that the in the training data site, mafic rocks and ultramafics can be well classified with very minor errors. And here are the results for prediction on the validating data site. The overall accuracy can be reached as 96%. And the confusion matrix shows that the mafic rocks, the ultramafic rocks can be well predicted based on our result. Another result we can check is the Gini index, as Jeff also mentioned that Gini index can be used to determine the best predictor for predictions. Here we can see that chromium, nickel, zirconium, magnesium, titanium, and selenium and cobalt as they are the most important variables to discriminate the major lithology. And these results are quite similar with our previous PCA result. And also we use receiver operating characteristic curve, which we named as ROC curve, to evaluate the performance of our random forest model. Here we can see that the intermediate mafic rocks, ultramafic rocks can have a very good curve that's close to the perfect predictions. And also we use the AUC to evaluate, which means area under the curve, which has a very good performance from 0.8 to 1 to show the ability to predictions. In addition, we try to compare other different machine learning techniques, such as we compare the random forest neural network and the K nearest neighbors, classification trees, and the naive Bayes for our training data. And we can see the most important is the classification. Is the classification accuracy that random forest and neural network show very high accuracy, which means that they show very good ability to prediction. Here is a summary that the major lithology variations can be captured by the major principal components along the two deformation zones along the Larder Lake transect. And the remaining principal components can reveal potential gold mineralizations. And the random forest is a powerful machine learning tool to predict rock types in areas that has a similar lithostratigraphic structure. And our next work is to integrate more geological information from the database, such as the geophysical data, like other fault, and to build our mineral potential maps. And especially we will use some random forest and a neural network. Thank you.